Okay. So right now we're gonna do similar figures. All right. So similar figures, basically you have two shapes. Of course, they're the same shape and they're different sizes. So in this case, we have two triangles. All right. They're the same shape. They face the same direction, but they're different sizes. So the one thing that we want to do is we want to set up proportions. So basically, we want to compare or kind of see what side is the same as another side. So in this case, you have AB is similar to ED. So that means this 3, which is on the left side, is similar to this 6. And AC is similar to EF, which means this bottom side, this 4, is similar to the X. So you're trying to find the value of X, the missing. All right, so first thing we want to do is set up proportions. Everybody has their own way, and it really doesn't matter which way you set it up, just as long as you're consistent. So I like to start with the two lengths from the same triangle, same figure. So I have 3/4 equals, and remember I said 3 goes with 6, so that means that to be across, and then 4 goes with X. All right, 3/4 equals 6X. All right, so there are several ways that you can do this. You could do it something what I like to call it rainbow, which is a scale factor, or you can do cross multiply divide. So I'm gonna start with cross multiply divide, or CMD. All right, so I'm going to have this. So 6 times 4, if you know your multiplication facts, this gives you 24. All right, and with that 24, you're going to basically divide by the remaining number, which is the 3. And 24 divided by 3 gives me 8. So my answer would be 8. All right. Now, if I wanted to cross multiply divide, say the same, not cross multiply divide, scale factor, or the rainbows like I call it. So 3/4 equals 6X. I can do like this. What times 3 gives me 6? Times 2. All right. So whatever I do to the top, I do to the bottom. A little rainbow. 4 times 2 equals 8. All right. So either one works.